Alright, let's continue to work on implicit differentiation. And I'm going to get started by taking d dx of both sides of the equation. Oops, that's an ugly x. Equals d dx of 9xy. Okay, so I can simplify this a little bit more, and I can split up the x cubed and the y cubed. So I can say d dx of x cubed minus d dx of y cubed equals 9 d dx of xy. I can always take out the constant basically from inside the derivative if it's multiplying the variables. So d dx of x cubed is pretty simple. We're just going to need to take to use the power rule. We're going to bring the 3 down, subtract 2 from it, so the derivative will be just 3x squared. Now, d dx of y cubed is going to be equivalent to d dy of y cubed times dy dx, because we're doing the implicit differentiation of it. And now we have 9 times the derivative of x times y. X times y. So we're going to need to use the product rule since we're multiplying the two of them. And that's going to look like this. X untouched times the derivative of y. So I can say x times d dx of y plus d dx of x, put brackets around here, times y. I should have used the square brackets and other brackets outside, but I guess you guys get the drift. So anyways, here we still have 3x squared. Now d dy of y cubed is just going to be 3y squared. And the dy dx stays right there. And right now, inside the brackets here, x times d dx of y. D dx of y is just going to be dy dx. So basically we have x dy dx. And d dx of x is just 1, because the derivative of x is just 1. 1 times y is just y. Now I can keep the left side of the equation of the equal sign untouched. And I can distribute the 9, multiply into over here and over there, and I get 9x times dy dx plus 9y. Now what I can do is that I can bring all the terms with dy dx to the left side of the equation and everything else to the right side of the equation. So basically, let me just quickly pick another color here. I'm going to take the 3x squared over to the right, and I'm going to pick this guy and shift it over to the left. That way I can factor out a dy dx and solve for it, which is what we're looking for. Now, so we have negative 3y squared dy dx minus 9x dy dx equals 9y. Oh, that was an odd 9. 9y minus 3x squared. Now I can finally factor out the dy dx. And negative 3y squared dy dx divided by dy dx is just going to be negative 3y squared. Negative 9x dy dx divided by the dy dx is just going to be negative 9x. And that's just equal to 9y minus 3x squared. Wow, I could have divided everything by 3, but I guess I'll do that later. Finally, I can actually just divide both sides by negative 3y squared minus 9x over negative 3y squared minus 9x. So these guys cancel out, and dy dx, which is what we were looking for, is going to be equivalent to 9y minus 3x squared over negative 3y squared minus 9x. However, I want to divide top and bottom of the fraction by 3 to make things look nicer. So that's going to be 3y minus x squared all over negative y squared minus 3x. And that is our final answer. You could quickly rearrange it and make it basically, because we have a negative here, a negative there, So multiply top and bottom of the fraction by -1. And then we would end up with x squared minus 3y all over y squared plus 3x. But many teachers would accept the final answer like that. But I guess it looks slightly nicer like this because it's more positive. Anyways, I hope you enjoyed the solution, and we have many more similar videos right here on this website. Thank you.